Now look at the questions. Okay, now I have the zinc and the copper plate. So among the zinc and copper plate, can everybody, can you answer to me what is we are located on top of the electrochemical series between zinc and copper? Yeah, the zinc. What become the negative terminal? The zinc will become the negative terminal. Then when the zinc become the negative terminal, we are going to write down the half equation. Okay, you may jot down the half equation in the paper first. Hey, because we know that zinc will tend to lose electrons. So what happens is Zn becomes Zn2 positive plus 2 electron. Hey, now the question is, okay, now we have a look. If the electron that we write down on the right hand side of the equations, so what does it mean? Maybe Sokin, can you explain to the friends?
Lose electron.
Correct, lose electron. When we write down on the right hand side, we call it as lose electron. And in the electrolytic cell, we learn the mnemonic. We say that lose electron, we have the short form we call OIL, correct? Jinpei, can you tell the friends the mnemonic, the terms that we learn OIL, what's the meaning?
Oxidation is lose electron.
Correct, okay, oxidation is lose electron. So when we say oxidation lose electron, where they are going to occur. So whether the place that occur the oxidation, or maybe you think?
Anode.
Yeah, we call it as anode. Right, then next one. What are the cation present in the solution? Okay, anybody can give me the cation present in the solution? Hey, Nanchen, okay, right?
Copper 2 ion and hydrogen ion.
Thank you. Hey, among the copper ion and the hydrogen ion, okay, let's have a look on the electrochemical series. Copper and hydrogen, which one located at the bottom? Copper. So who is going to receive the electron? Copper ion or hydrogen ion? Copper. Copper 2 ion will receive the electron. So how are we going to write down the equation? Hey, this Cu2 positive will gain the electron, then be turned into the copper atom. Hey, so help me to write down the answer for the equations. Okay, now we turn another one. Okay, just now we say that if the electron is located on the right hand side, we call it as loose electron, right? Okay, so now if I write down the equations with the electron on the left hand side, okay, or maybe Hariharan, can you help me? Okay, on the left hand side, what does it mean?
Gain electron.
Gaining electron, correct. So we have the mnemonic, we say Rig. What is Rig?
Reduction is gain electron.
Correct. So over here we say that oxidation occur, we call it as anode. When the place that occur the reduction, what is the other terms for that particular place? We call it as, one is anode, another one is called cathode, correct. Okay, what I want you to do is, we are going to try the questions and you are going to understand what is inside the chemicals and how to write down the half equation. Okay, let's try this question. Okay, you may work in pairs. Okay, discuss with your friends and what are the chemicals used. Number 2, I want you to write down the half equation for the negative terminal and also the positive terminal. Yep. Okay, now we want to check the answer. Darshan, can you help me? Okay, try to write down the equation that you get from the negative terminal. Okay. Okay, thank you. Have a seat. Okay, so now we want to double check. Okay, is your answer exactly the same like Darshan? Yes, right? Okay, so that's correct answer. Meaning that we say whenever the zinc and the iron pair together, zinc will be the more electropositive metal. So the zinc will act as the negative terminal. That's why the zinc will lose the electron. Just like what we say just now. The moment we write down the equation, the zinc atom will turn into the zinc ion. And from here, when we write down the electron on the right hand side, what does the mean? Lose electron. Okay, lose electron. We have the term we call OIL. What is the meaning of OIL? Oxidation is lose electron. So this is the reaction occur inside the negative terminal. Okay, go back again to the diagram. Hey, now, after losing the electron will move from the zinc plate, go through the wire until the iron plate. And now, here we go. It will enter to the iron plate, and the electron will be received, according to the theory, received by the cation in the solution, correct? Hey, now we want to know what is the ion, or we say that what are the cation that present inside the lead to nitrate solution, or Hong Wei. Okay, so what is the
Pb2 positive ion and H positive ion.
Okay, correct, thank you. So the Pb2 positive ion, or we say lead 2 ion, and the hydrogen ion. Among these two ions, which ion will be located at the bottom in the electrochemical series? Pb and H, which one? H, right? Okay, H. So we know that the hydrogen ion will gain the electron. And how to write down the half equation? Right, Wei Guan? You can try. Hey, just write down the positive terminal. Okay. Okay, thank you very much. Okay, is it correct? So, yes, is it correct? Yes. So, from here, once again, we know in the positive terminal, because the ion that located at the bottom will tend to gain the electron. So, when you compare between the Pb2 positive ion and also the H positive ion, so this H positive ion will gain the electron. From there, they will turn into the hydrogen gas. Okay, then now we proceed again for a while. Just now we mentioned the zinc and the iron plate. So zinc will become the negative terminal because zinc on top. Okay. Then number 2, the metal that tends to become the negative terminal will lose the electron. So what we have? So we will have the equation and exactly like what our friends write. Right. Then just now we say that the moment we have the electron on the right hand side, what is the meaning? Lose electron, right? After losing the electron, so this is a process called oxidation. And where the location oxidation occurs, we call it as anode. Yep, we call it as anode. And in the positive terminal, when the electron move into the solution, we know that what are the cation present? Pb, Pb2 positive ion, some more H positive ion. And from here, we know that the hydrogen ion will gain the electron to become the hydrogen gas. So this is a reaction occur inside the voltaic cell in order to form the electricity. Because the moment there is a transfer in the electron from zinc go to the iron, once the electron move, they will generate the electricity. That's why we say that voltaic cell is capable to form the, or we say to generate the electricity through the chemical reaction that occur inside the cell. And another one, we say that electron that located on the left hand side, we call it as gain electron. So what is the meaning of RIG? Reduction is gain electron. Okay. So when reduction gain electron, it will occur, the place that we call is called as the cathode. Right. Now we want to move to the Daniell cell. Actually, if you look properly to the Daniell cell, we learn is the normal simple cell. So now we have a look on the Daniell cell. Okay, inside this Daniell cell, any different compared to the simple cell just now? How many beaker that they need? 2. Okay, how many solutions that we need? 2. Just now the simple cell just require 1 solution. But in the Daniell cell, we need 2 solutions. But the concept behind is still the same. If you look properly, here we have 2 beakers. And in between the beaker, actually there is a connections. If you want to look in detail, okay, you can flip to the textbook. Okay, page 105. Okay, look in details the diagram. Can you see that 105? The diagrams? Okay, in between there is a U-tube. Okay, we call that U-tube. Then this U-tube acts as the short bridge. And another way, sometimes we can also use 2 containers. One is the beaker, another one we call it as the porous spot. But we still use 2 different solutions. This is called Daniell cell. Then this Daniell cell we will learn in detail in the coming lesson. So today we just touch a little bit what is the Daniell cell that may link together with the same concept of the voltaic cell. Okay, so now maybe you were to say, sir, inside the cell just now we just have 1 simple solution. But inside the Daniell cell we have 2 different solutions, right? Then we have the short bridge. We also have the porous spot. So what is the function of this thing? Hey, number one, it says that what is the functions of the salt bridge and the porous pot? Hey, one is to complete the circuit by allowing the movement of the ion. Then number two, this is to separate two different solutions. So that is why we need the porous pot, or maybe we need the salt bridge. Right? Because we are using two different solutions. We need to connect them together so that there will be the movement in the ion. Hey, continue. So now we want to have a look on the equation. Okay. So what I want you to do is, once again, you try to discuss with each other. I will guide you. Then we want to write down the equation. According to the diagram over here, zinc and copper, which one will become the negative terminal? Zinc, right? Okay, zinc will become the negative terminal. So help me to write down the half equation in the negative terminal. Okay, just now I go around, basically you all have the correct equation for the negative terminal. So now, we know that this zinc strip is going to lose the electron, and this electron will follow the wire, move to the copper strip. But the copper strip itself will gain the electron first, but this electron will go to the cation in the solution. So this copper strip is deep inside the copper 2 sulfate solution. So what are the cation inside the copper 2 sulfate solution? We have Cu2 positive, correct? Then some more SO4 2 negative sulfate ion. Then some more. Okay, H positive ion. Then OH negative ion. Okay, we only focus on the cation. So what are the cation? Cu2 positive. Okay, then H positive. Okay, among the Cu2 positive, look at the electrochemical Cu2 positive and H positive. Which ion will be selectively discharged? Which one you are going to choose? Cu2 positive ion. Okay, then now help me to write down the half equation in the positive terminal. Okay, clear. Okay, clear. Yes, that's right. Okay, clear. Okay, basically you all have the correct equation. So now we just double check only. Okay, according to the equation, half equation, just now exactly like what you write, Zn becomes Zn2 positive, lose electron. The electron move to the copper strip. But this electron will be gained by the cation in the solution. So we have copper 2 ion and hydrogen ion. Copper 2 ion will receive the electron, then will become the copper atom. Hey, then this is called half equation, whereby you can see the electron. So now we want to combine the half equation to form the ionic equation. Okay, how are we going to form the ionic equation? A moment. Hey, just now in the negative terminal, we have the zinc, then it turned into the zinc atom, turned into the zinc ion by losing 2 electrons, correct? So on the positive terminal, we have the copper 2 ion. Then this copper 2 ion will gain the electron to become the copper. So when we want to combine these two half equations together to become the ionic equation, first of all, you have to check the electron. Do they have the same numbers of electrons? Yes, right? Okay, so whatever inside the left-hand side of the equation, we have to copy back. So I have the zinc, I have the copper 2 ion, and 2 electrons. On the right-hand side, what I have? Okay, right. Then 2 positive plus Cu. Okay. So now what I want you to do is, let's focus on the equation. Anything is the same in the right-hand side and the left-hand side? The electron, correct? So this electron, actually we can cut it off. So the real answer for the ionic equation is Zn okay. So this is what we call the ionic equation. Then you can you help me to write down the ionic equation? Okay, clear? Then we continue again. Okay, last. Back again to the diagram here. May I know the color for the copper to sulfate solution? What is the color? Yeah, it's blue. So why it is blue color? Actually, the blue color comes from the copper to ion. Due to the presence of copper to ion, that it can show the blue color. So now I just want to ask you, based on the equations only, okay, roughly we have to know Cu2 positive ion, later on they will turn into the copper atom, right? So slowly this copper 2 ion, they will turn into the atom and it will decrease, right? What is the color change of the blue copper to sulfate solution? Wilson?
Blue solutions turn paler.
Correct. Blue solution will turn paler. If you ask me, sir, why it turn paler? Or maybe Melvin, can you help me? Okay, why the solution turn paler?
Because the concentration of copper 2 ion decreases.
Correct. Because the concentrations of copper 2 ion decreases. Right? So this is what we say. The blue solution will turn paler. Why? Because the ion that in charge of the blue solution is copper 2 ion. The moment the copper 2 ion already changed into copper atom, the concentration itself inside the solution becomes decreases. So from there, we will know that the color start to fade. That means the blue color will turn paler. Okay, so can you help me to write down the reason over here inside the handout? Right? Maybe this is end of the topic, end of the subtopic today, and we are going to repeat again, roughly again about the Daniel cell, and we are going to talk further again in the Daniel cell in the coming lesson. Right? So before I finish, so maybe we are going to go for the conclusion. So what we learned, okay, try to recall back. First, we say that voltaic cell, what are the conditions that must have in order to form the voltaic cell? What we need? Correct, two different matter. But these two different matter must be placed inside the electrolyte, correct? Okay, we must put inside the electrolyte. Then we have three phases to go in order to understand the concept behind the voltaic cell. Number one, we say that metal located on top will become the negative terminal. So what happened to the negative terminal? Loose electron, correct, loose electron. Then the electron will transfer. The moment the electron transfer, that means they will form the electricity. But the electron will be gained by the cation in the solution. So from there, we can see the half equations for the negative terminal and also the positive terminal. Okay, then that's it.